Welcome to Heriot-Watt University and to be a robotics engineer for a day. Today is all about robotics. We'll be looking at the role engineers have to play in developing robotics for the future and the role that robotics have in society, in manufacture, in autonomous vehicles and so many other applications. Here's one that I have beside me. This is Popeye, named because he's a big strong arm. But also, what's important, not only with the strength, is the precision and accuracy that Popeye has. So Popeye has been performing the same task over and over and over, so many times, and it does it with incredible precision. And that's what makes Popeye able to produce really good and accurate things like in manufacture, whether they're welding a door onto a future automobile or whether they are working as part of a food and drinks manufacturer or production line. The accuracy and precision of repeated motion is what's so very important and so very useful of this robot. But as you follow me around, I'm going to show you a couple of other applications that robotics have. And this one here is setting up today's task. What we have here are a range of little robots, and they are discovering and exploring their environment. So these little robots have sensors, and as they move around their environment, they're making sure they don't bump into things. They are avoiding obstacles. They're also making sure they don't bump into each other. So they are learning about their environment, they're conscious and aware of their changing environment, and they're making decisions all the time. And that really today will be what you'll be working on. You will be developing a robot to avoid obstacles, and in so give it its first step towards exploring and discovering its own environment. Now beyond that, once a robot is familiar with its environment, it becomes very powerful, very useful, because it can then begin to make decisions that can help it do very complex and important tasks. So maybe in future these robots will remember their environment. They will know where things are. They'll know what moves and what stays put. And if you give them a task, they might find the optimal path to go from A to B, avoiding things along the way. And as robots like this become more and more intelligent, as we develop artificial intelligent algorithms, they're able to become more aware, make better decisions, ones that we haven't necessarily directly programmed into them, and producing or delivering on very complex tasks very efficiently. So as we go today, you'll be working on a robot that looks something like this. You'll be designing and developing the electronics of this robot here, and you'll also be programming it. So a robot like this has sensors. These sensors in the front help it predict when it is close to something. It has motors on the back that make these wheels go round. And it has intelligence on here. It's printed circuit board that's able to make decisions based on knowledge and appreciation of its local environment. So that's the task that you will be taking today. You'll be designing the electronics as well as the programming and the knowledge or the decision-making algorithm that is associated with this robot. But before we go any further, I want to give you one example of how robotics are working in everyday society. And a particularly fun one, a particular one that close to my heart is the Robo Cafe in Festival City. I'm going to hand over now to Mohammed, who's at the Robo Cafe, showing you how robots are currently and will in future interact with you and me on a daily basis.
Hey, thank you very much. Hello everyone and welcome to this session. So I'm going to catch up my order here, but I'll tell you more about what's going on. So this one in particular is delivering the orders, and we got the 3 arms, which we'll talk about them in a second. Navigating its way within this environment, which is sort of, preset, but then there will be always obstacle which might be present. This could be the other robots around or something on the track. They will always stop when they reach the island they're supposed to be in. And you can see this island in particular servicing 2 tables at this stage. There are always sensors around. I'm sort of trying to cheat here and blocking one of the sensors to keep it around. This robot in particular has 2 wheels, but then have another 2 to balance it. So you can imagine by changing the speeds of these two wheels, you can manage turns, maneuvering, and then navigating its way. On a busy day, there might be multiple robots going all around these islands and trying to deliver orders as they go. Thinking about these robots, they are really electromechanical systems. There are mechanics, there are aspects of transferring that energy into wheels and turning around. Electronics does all the control, but also a bit of coding that you will have experienced today in our session. Obstacle avoidance is sort of, step one into getting into autonomous vehicles, autonomous robotics. So they start to link what they see around them. They see that is machine vision kind of see by detecting range and distances and then navigate their ways through. They will have to take decisions on their own, but there are also some settings about the parameters and what happens around them taking place in there. So that's key thing to start with. It depends on the application. You will choose different sensors. Think about cars, navigating the roads with all what happens in a busy road or intersection, checking on the traffic lights, traffic signs, and then managing to navigate their ways. And the UAE and Dubai are starting to allow testing for autonomous vehicles on the road. So you will see them in the road next to you very, very, very soon. And that also brings to attention how this market is expanding really rapidly, how your skills are really required to fall into all these gaps. Now, I'll probably do another demo to show you what happens with the robotic arm and talk about it a little bit. So you'll see the demonstration going really fast is a bottle of water. These robots are also now programmed within this cafe to do mix of different varieties of fresh orange juices, also coffee. So a bottle of water. Now that robotic arm is using a number of joints, a number of links to do what you see it's doing. It's very aware of its surrounding or the world of the robot, if you want to call it. And you can see these black boxes at the back. These are the servo motors that does all the turning. But remember, there is always a brain required. And that's currently under the table. And that's where you put all your program. Now watch this. See how smart is that robot or the people who programmed it. By putting the bottle on the side, because the bottle has a high center of gravity that might fall on the way. And that is going to now hopefully get that bottle of water to me. You can see another robot is moving, probably to get into another order. This is a great example of navigating while in a busy environment, using all the sensors to move around the place and deliver orders safely. So that takes engineering. It takes some skills knowing the task you are dealing with. It takes also, when you deal with humans, ethics. And we are, as engineers, we are always responsible of the system that we deliver and make. Think about how long this robot should work per day. How about the battery? How do you put all consideration of getting the load delivered safely? Think about coffee, for example, juices, and so on. And that is really a good example of one of the applications. And there are many, many, many applications of robotics nowadays. It finds its way all the way to the destination and normally turn to point to the right table because, there might be two tables and you don't know which order is that table to. And now I know that this is here. I will have to obviously get it up myself, or otherwise maybe I'll lose it. Let's find out. Will you take it back? What do you think? Will it take it back, or is it detecting the weight on the top of this? This or that. So, getting back to the robotic arm, it's very important to understand if these robotics arms are universal robotics arm. This have at the end, and you can see probably a cup holder that's fixed on the end of the arm, which we call it end effector. This could be very well doing welding somewhere, or material handling, or anything else. So find out more about all this in our session today, and I'll get you back to the labs very soon.
Hello, I'm Suri. I am Associate Professor in the School of Engineering and Physical Sciences at Heriot-Watt University. And today we are going to simulate obstacle avoidance robot using Arduino Uno and the distance sensor. The heart of this is the Arduino Uno, which is a microcontroller, because it has I/O pins here, and there is a distance sensor. This is a distance sensor. Whenever the robot is sensing any obstacles on its way, so that it can take corrective actions. Then, of course, to drive these wheels, we need motors. Okay, so they're using the motors, which is driven by this Arduino, and as well as to drive motor, we need driver ICs. Okay, so L293 driver IC is used, and to power, we need battery. Okay, these are the basic components they are using to simulate. Since it is online, so there is a software called Tinkercad. Why we use Tinkercad is first of all, it is a drag and drop interface, and second one is Arduino based projects can be easily executed online using Tinkercad. So first, you are doing simulation of one-wheel robot. Okay, you have to program it and show your program. Okay, it should work. Simulation results, you have to show it, and in that you have to show the codes for stopping and reversing the rotation of the motor. What code you have, what manipulation you have done it in your code, that you have to show it. Later on, you have to control, you have to develop a program for two-wheel robot. Okay, so both the two wheels must be controlled. Whenever there is an obstacle, it should stop. Okay, and if you can write a code for turning left and moving forward, that is also well and good. But at the end of the day, what I am expecting is that you should control two-wheel robot. This is a guidance video on obstacle avoidance robot simulation. When you log into Tinkercad, you can get the screen like this. Click circuit, click create new circuit. You will get the screen like this, and this is the workspace where you have to drag the component and place it. So we need breadboard, Arduino Uno, DC motor, distance sensor, 9 volts battery, L293D driver, and so on. So first search breadboard. Okay, you have to keep the left mouse button down to drag and drop in the workspace or work area. If you want to rotate it, first it will become blue. You have to select this and press rotate button till you get like this. Okay, so I want to minimize the size. You can, using a mouse, you can do it. You can drag and place it here. Next, we need Arduino Uno. Search here. So you can see Arduino. Keep the left mouse button down to drag and drop it in the work area. Okay, so next we need the 9 volts battery. Okay, you can rotate this. And you can move it up by keeping the left mouse button down and move wherever you wish. Next, we need the motor driver IC, L293D. L293D. So this is a, you have to keep the left mouse button down, drag it and place it here. Be careful when you are connecting this. So you should connect like this. That means these 8 pins should be fit into these holes in on the breadboard, and these 8 pins should be inside these holes in the breadboard. Okay, because breadboard connection diagram you can see annex 1. All right, next we need, first we'll simulate one-wheel robot. That means we need one hobby geared motor, that is this. and we need, this is a geared motor, and we need distance sensor to check whether the robot is, any obstacle is present or not. Okay, so this is the distance sensor. So now we have to wire the components. So to wire the components, how to do, I have given in the guidance note. Okay, so it is very simple. First you have to power this breadboard. All right, so how to do that? Placing the cursor on end of a component, you can see a 5-volt supply. You can see a red square will appear. Hold left mouse key down and connect it to the breadboard. Usually positive terminal of the power supply, we are using red color wire. You can change the color of the wire. Okay, to red, you click here and select red. And ground, that is the negative terminal of the power supply. So we'll connect it to here. So you can adjust the length of the wire by keeping the left mouse button down. Okay, and we'll use a black color. So now this complete holes, or this column will be positive of the supply in the breadboard, and this complete column will be the negative of the supply. You can see here, right? Next, I will also want to make positive and negative of the power supply on this side of the breadboard as well. So just take a connector wire, red square will appear, right? Hold left mouse key down, drag to the end of the connecting component. We have to connect it here. Okay, so change it to red, and this one to black. This is negative. Okay, black color. So now we are getting 5 volts here, plus 5 volts, ground here, and here also 5 volts and ground. So this IC has 16 pins. Pins will be, no, usually any IC, it is counted from the, there will be groove given by the manufacturer. You can see here white color groove. Pin numbers are counted from here. This is pin 1, pin 2, pin 3, pin 4, up to pin 8. 8 pins on the left side. Pin 9, 10, 11, 12, 16. This is the 16th pin. So remember, these 8 pins will control one motor. These 8 pins will control other motor. If you want to control 2 motors, you can control 2 motors using single IC, single driver IC. I will be using these 8 pins, but no ground should be left open. On the left side 8 pin also there is a ground pin. You can see here 2 grounds. So you have to connect it to the negative terminal of the power supply, and this ground also must be connected to the negative terminal of the power supply, and you have to enable this. Okay, enable means you have to give 5 volts, so make it to red color, connect it to the positive. See, it is connected to the positive. So similarly here also power 1, you have to power this IC, so you have to connect it to the positive. Okay, here also enable is there, you connect it to the positive. Here also there are 2 grounds. Okay, so connect it to the negative terminal of the power supply, that is here. This is negative, you can see here, already connected to the negative here. Okay, and color I have to change it to black, and this also should be connected to negative. Remember, these pins are shorted, these pins are shorted. Okay, you can see the connection, green color connection will appear. Okay, now I need 9 volt supply to this to power this. Okay, positive terminal of the battery it is, and so I will use red color. And negative terminal, always you should not keep any ground open, otherwise it will not work. So negative terminal should be connected to the negative. All negative of the power supply must be connected. Okay, so black. So this is over. Next we have to, pin number 9 is this over. Pin number 10 is input 3. So this input 3 we have to connect it to the Arduino. So red square will appear, you can see here. Any connection can be taken from any one of these holes. Okay, so I will take it from here. Okay, input 3 I'll connect it to, in the guidance note I will connect it to the D5 pin of the Arduino. Arduino has 14 digital IO pins. You can use any one of the 14. There are 14 digital IO pins on the Arduino. Out of this, 6 is capable of PWM, and you have 6 analog input pins. Okay, so you have to connect it to any one of the 14 digital IO pin. So in the guidance note, I have used orange color for this, so I will use the same orange color. Okay, so pin number 9 is over, pin number 10 is over, input 3, pin number 11 is output. So the output of this IC should go to armature of the DC motor, right? So take here armature positive terminal. Okay, so you can adjust the length. So make it red. All right, next 9, 10, 11 is over, 12 and 13 are ground, already connected. 14 is output 4. Output 4 should go to negative terminal of the armature. Okay, I can adjust the length. So I'll make it black color. Okay, then pin number 15 is this. It goes to input 4. Input 4, we have used D4 pin in the guidance note, so I will use the same pin. Of course, you can change it, but you remember which pin is used, because that is required while coding. So I've done it. Okay, so D4. Okay, so I've used green color in the lecture guidance note, so I will use green color. Okay, so this finishes the motor connection. Now we have to connect the sensor, so it requires 5-volt supply. That we will give it to the, already we have brought the power supply from the Arduino and we have connected to the breadboard. So it is plus 5-volt, so we have to use red color. That is a good way of wiring. And this one to ground means negative terminal of the power supply. Connect it to the, we have to use black color. Now there is a trigger and echo pin. You can see a trigger pin and echo pin. It is just like if you want to, in a gun, if you are pressing the trigger button to fire the bullet, right? So in the same way, it does the same thing. So this should be connected to the Arduino. So I have used trigger pin in the guidance note. I have connected to D9 pin of the Arduino. So I will use the same thing, and I've used orange color for this. So we'll use the orange color. Okay, then echo pin I have connected to pin number D8 of the Arduino, right? So D8 of the Arduino. Okay, and I've used yellow color. In the guidance note, we'll use the yellow color. So this completes the wiring. Now we will start coding. Press the code. Write the code. One is only using scratch blocks, or blocks plus text, or text. So I will use blocks plus text because we are familiar with scratch. scratch command, whenever you are dragging and placing it here, it generates C++ code here. This C++ code can be used for the Arduino. So by default, it has a blinking LED code, so which we don't want. You press it here. Now we have to keep the variable as the distance. Click variables here. Set the variable as distance, say dist. Okay. So keep the left mouse button down, drag and place it here. So now set distance to read the ultrasonic distance sensor, right? So here you can see the input, read ultrasonics. You keep the left mouse button down and drag and place it here. Okay, set distance to minimize this, you can't see. Trigger pin, we have used it as pin number 9 on Arduino, and echo pin we have used pin number 8, right? So here you have to select pin number 8. Next we have to print the distance, so go to output. So you can print to serial monitor. Which one? Distance, not this. So go to variables, select distance is the variable, and then I will wait for 0.5 seconds. Now I have to write the program for our robot. Okay, I will use if then else command. I'll zoom it. So go to math, you have to compare it, go to math, keep the left mouse button down and drag and place it here. Here we have to compare the distance, right? If the distance, go to variables, select the distance is less than or equal to 100 centimeter, then motor should stop or robot should stop, right? So output will be how it can stop that. If this statement is true, then control will be, we have given the motor control pins are D4 and D5 on Arduino, right? So we have to set pin number 4 to high and set pin number 5 to high. If both are high, then it will not work. If the distance is if this statement is false, that means if the distance is greater than 100 centimeter, it will execute the program what we are writing here. Okay, then set pin number 4 to low and pin number 5 to high. That's it. This will control one motor. So how to run the program? So see here, now it has automatically generated C++ code, whatever command you have dragged here. So this we have to copy it on the Arduino software. Now to check whether your program is working or not, go to start simulation, press this. Okay, now click this. Now click, bring your mouse here, keep the left mouse button down. You can see the distance. Distance now is 113.4 centimeter. Distance of an obstacle and a robot is 113.4 centimeter. As per the program, the motor should, or robot should move, right? So look here, motor is rotating at 244 RPM. Now, if the distance is 100 centimeter, less than or equal to 100 centimeter, robot should stop, right? Look here now, the distance is 91.5 centimeter. The motor speed is 0 RPM, means it has stopped. The whatever codes, scratch code, you are dragging and writing it, okay, placing it, the blocks, the scratch blocks. So it automatically generates equivalent C++ code, and those code can be copied into an Arduino software here, okay, in your laptop. Then connect the USB and connect this one to your Arduino. So if you click it, so it will burn the code on this Arduino processor, and Arduino processor will take care of the control in reality. Basically, this is what is used in most of the industries these days to deliver inventories, okay, to deliver the goods from one department to another department. This is the basic principle used.
So now we get to the fun part. You've programmed in Scratch, we've translated into Arduino language, which means we're able to download it onto this microcontroller, the controller that essentially feeds information from the sensor to the action bit, to the motors that makes it go forward. So let me test it first in my hand as I turn it on. The wheels should turn, as they do. And when I put my hand in front of it, it should stop. Let go. And stop. Okay, so it seems to be working. But let's now find if it's able to explore its environment. It's going to come your way, Mohammed. I'm going to point it this way and turn it on and wait 2 seconds. 1, 2. It's on its way towards an obstacle and it stops. Brilliant. Seems to be working. So Mohammed, over to you. What would be the next stage of programming or making this device more intelligent?
Well, now at this point of time, it's able to explore its way. But then what about the other surroundings? So looking around maybe and deciding which way should be going, learning and remembering the environment around it is a very important information that the robotics are going to build over and over. And this is what we call it machine learning, where these systems start to be on autonomous behavior, to be able to interact with other robots and with the humans to form a full functional system that evolve over time. So what you have done today is really that seed, and that can grow, and the limit is only your imagination.